Okay, hello guys, welcome back to my channel. Nerdy is the name. So today we are going to discuss briefly about the bijection method. Okay, see here, uh, as I've taken this, first we'll see the procedure, then you'll understand clearly. Okay, so see, procedure. Here see procedure. Let f of x is equals to 0 be an equation. Equation as in our transcendental equation. It can be anything. So I'm taking a e power x, x e power x minus 1. This also it can be, or cos x minus x. Anything it can be. Transcendental equations. Okay. See. Now find a and b such that f of a is less than 0 and f of b is greater than 0, or f of a and f of b is less than 0. So like this. Okay. Here f of a should be less than 0 and this is should be greater than 0. Okay. In such a way that we have to find a and b. Like you substitute the values and you see, first you substitute 1 in this, and if we 0 in this, if we get less than 0, no, if we substitute 0 and f of 0, if we get less than 0, no, take that value. Again you check f of 1 for this equation only. You check f of 1, that we get greater than 0, no, so take that values as a and b. So a is 0 now, this b is 1. Okay. And if we multiply f of a and f of b, since this value will get negative, no, so then it will be less than 0. So in such a way that we have to take. If I will do more examples, no, you'll understand. So now first approximation. Now x1, how to take x1? x1 is equals to a plus by b by 2. Whatever value we've taken, no, 0 plus 1 by 2, that is x1. Then calculate f of x1 and find its sign. Second approximation. If f of x1 is less than 0 and f of b is greater than 0, then x2 is equals to x1 plus b by 2. So here you see, first you have to calculate x1, right? A plus b by 2. Then f of x1. If it is less than 0, okay, then its sign is negative, no? Sign is negative. Then how to take second approximation between f of x1 and f of b? Here if you see here, so see x1 is less than 0, no, so now second approximation is between x1 and b. But if x1 is greater than 0, no, then x2 is between x1 and a. So like that, that's how we have to take approximations. Okay, bisection method. I'll explain a sum, then you'll understand clearly. So see here guys, here we have a problem, that is find the positive root of x cube minus x minus 1 using bisection method. Okay, first what we have to do in this, first you find f of a and f of b. So I substituted 0 here. What I'll get, first you start with 0. Okay, first you start with 0, no worries. I'll get minus 1. But again f of 1 also I got minus 1, no, so I can't take 0, f of 0. So next I have to continue with f of 2. I got positive value. So now a and b is 1 and 2. See here, a and b is 1 and 2. Now by bisection method, okay, our first approximation x1 is equals to a plus b by 2. So a plus b by 2. So a plus b by 2 is, here we have 1.5. Okay, 1.5. Okay, now we have to check this f of x1. Okay, we have to substitute the value of 1.5 in the given transcendental equation. So that is 1.5 whole cube minus 1.5 minus 1, and we got 0.875, which is greater than 0. So this is how you make sure to draw these. Okay, now this is f of x1 is greater than 0. So now if it is greater than 0, then it lies x2 lies between a and x1, right? This is a, this is x1. So here x2 lies between a and x1. Okay. Now you see x2 is equals to a plus x1 by 2. A is what? 1. x1 is what? 1.5 by 2. Now we got 1.25. Okay. Now we got 1.25. Now we have to find f of 1.25. Okay, whenever we find x1 or x2, we have to find f of that value also. Then here we got negative. Now this is f of a, this is f of x1. Now where does f of x2 lies? Here. You see here we got negative. So here f of x2, negative value we got. So what? Now this lies between this f of x2 and f of x1. Since we got negative value, no, we can't consider f of a because f of a also is a negative value. So now it lies between f of x2 and f of x1. Here this is f of x2 and f of x1. F of x3 lies between, okay, see, x1 and x2. Now x3 is equals to x1 plus x2 by 2. So that is 1.375. Now let's find f of x3. So here f of x3, this we substitute. Our equation you remember, right? X cube minus x minus 1. So in this we are substituting 1.375. We got greater than. So greater than means this is x2, this is x1. So this is x3. So x3 we got greater. So that means what? It lies between our next x4. Whatever x4 is there, no, it lies between x2 and x3. Here x4 lies between x2 and x3. So to find x4 you add x1, x2 plus x3 by 2. You do this, you will get 1.3125. Now f of 1.3125 we are doing. See, substitute that in that x cube minus x minus 1 equation, we will get negative value. Since we got here negative value, this is x2, this is x3. Since we got negative value, no, here x4. Now our current x5, it lies between x4 and x3. Now x5 lies between x4 and x3. See here. So now what did we do? x4 plus x3 by 2. Whatever we did, we got 1.34375. Okay. Now we are going to find f of, see here, f of 1.34375. When we got this value, it is greater than 0. So if it is greater than 0, here this is x4 and this is x3. Since it is greater than 0, so our next x6 lies between x4 and x5. Okay. Since x6 lies between x4 and x5, x6 is equals to x4 plus x5 by 2. And we got this value 1.32815. Now we have to find f of x6. Okay. That is greater than 0. So f of x6 is greater than 0. See here, x6 lies between x4 and x5. And since we found x6, it is greater than 0. Now the root lies between x4 and x6. Okay. Now we have to do is x7 is equals to x4 plus x6 by 2. Okay, we got 1.3201 and compare this one. This is 1.3. 2 points we got same here. See, so we can stop here. Sometimes they'll ask correct up to 2 decimal or 3 decimal or 4 decimal. Okay, in exam point of view. But here they didn't mention anything. So let's just stop here. We got 3 point up correct up to 1.32. Okay, so the root is 1.32, correct up to 2 decimal. So the root of what? X cube minus x minus 1. The root of this is 1.32, correct up to 2 decimal. So this is how you do bisection method. So in the next video I'll explain one more problem. So thank you for watching.